Hey guys, hope you're doing well. Today we'll be talking about divisibility rules for 9, 10, 11, and 12. Let's start with the divisibility rule for 9. Any number is divisible by 9 if oops, that's a typo. Let me correct that. If the sum of all digits is divisible by 9. Now, let's take an example. First, let's start with an easy example. Let's say 81. So the sum of these digits would be 8 plus 1, which is 9, and 9 is divisible by 9 because there's no remainder. It just gives us a quotient of 1. Let's try the same rule with a bigger number, such as 729. Now if I add these individual digits, that would be 7 plus 2 plus 9, which is 9 plus 9, which comes as 18. 18 is also divisible by 9 because 18 divided by 9 gives us 2 with no remainder. Now, let's try another number. Let's take 680. So if I add these digits together, 6 plus 8 plus 0, 0 doesn't really count, but 6 plus 8 is 14. Now if I divide 14 by 9, that gives us a remainder of 5 and a quotient of 1. And that shows us that 680 is not divisible by 9 because even though we added all digits, it wasn't divisible by 9, proving that 680 is not divisible by 9. And if I want to check that out, 680 divided by 9, well, that goes 7, which is 9 times 7 is 63. 68 minus 63, is 5, and then we take that 5 to the 0, so it becomes 50, and we leave that with a 5, leaving us a remainder of 5. The same remainder here for that. Moving on, let's try the divisibility rule for 10. Now, the divisibility rule for 10 states that any number is divisible by 10 if the number has a 0 in the end. Pretty simple. Let's take the number 680 again. If I do 680, well, is it divisible by 10? According to the rule, yes. Because it has a 0 in the end. But to double check, let me do 680 divided by 10. That goes by 6. And then leaves us with 8, which the 8 goes over to 0, leaving 80. So 68 with no remainder. Let's take another number, say 150. According to the rule, it should be divisible by 10, and to double check, let's do 150 divided by 10. That goes 1 and then 5 with no remainder, proving that this rule works. Now let's take another example. This will be our last example for the divisibility rule of 10. Let's take the number 125. Now, according to our rule right here, 125 is not divisible by 10 because it does not end in 0. The last digit is not 0. But let's double check that. 125 divided by 10 goes for 1, leaves 2. 25 divided by 10, well, the most that we could do would be 2, leaving us with a remainder of 5. And this proves that a number is only divisible by 10 if the number has a 0 in the end. Let's check out the divisibility rule for 11. So the divisibility rule for 11 states that Any number is divisible by 11 when you add and subtract the digits alternatively, and the resultant is divisible by 11. And one thing I want to add here, that if the result is 0, it's also divisible by 11. Now this rule sounds really confusing, but trust me, it is actually really easy. Now let's start out with a simple example. 132. Now what this rule simply states is that you add the alternative digits. So in this case it would be 1 plus 2. And then subtract the other alternative digits. So 1 plus 2 minus 3, which is 3 minus 3 giving us 0. Now, when we have a 0 as a result, that means this number is divisible by 11. And let us double check that. So if I do 132 divided by 11, that goes for once, leaves us a 2, and we can take 2 over to the top, 22, which gives us 12, showing that there is no remainder, proving that 132 is divisible by 11. Another example would be is the number 506. Once again, add the alternative numbers, so 5 plus 6 minus 0, which would be 11 minus 0, which is 11. According to the rule, if the resultant is divisible by 11, then this number, or any number, is divisible by 11. And 11 is obviously divisible by itself because it leaves no remainder. But we need to double check whether 506 is divisible by 11 or not. Let me get rid of that. Okay, so 506 divided by 11 is 4, leaving 6 to go to the top with 66, so 46. And that shows us that there is no remainder. For the divisibility rule for 11, I'm going to give 2 more examples. Let's take a slightly bigger number, let's say 1023. Now, if I add the alternative, so in this case, it would be 1 plus 2 and 0 plus 3. So 1 plus 2 minus 0 plus 3, which is 3 minus 3, giving us 0. According to the rule right here, this number should be divisible by 11, but one second, we need to double check. So 1023 divided by 11 that goes 9, and then that leaves us 3, so 93. And that there's no remainder. This is going to be the last example for the divisibility rule of 11, and that is 333. Now, if we try this rule, that would be this, and this would be alone, so it would be 3 plus 3 minus 3, which is 6 minus 3, leaving us with 3. Now, according to the rule, this number cannot be divisible by 11 because 3 is not 0 and 3 is also not divisible by 11. But let's double check that. 333 divided by 11. Now that goes for 3. And here, then it would be, oh, that went to highlighter mode. There you go. 0. Sorry, still in highlighter mode. Giving us a remainder of 3. And so this example shows that when the result is not divisible by 11, and if it's not 0, then the number is not divisible by 11. Moving on, The divisibility rule for 12 is any number is divisible by 12 if it is divisible by both 3 and 4. In one of my previous videos, I have explained the divisibility rule for 3 and 4, but just to brush up, the divisibility rule for 3 is the sum of all digits have to be divisible by 3, and the divisibility rule for 4 is the last two digits have to be divisible by 4. Let me fix that. So let's start with an example. We're going to go easy here. Let's take 24. Now, for 24 to be divisible by 12, we have to check whether it's divisible by 3 and 4. Let's start with 24 being divisible by 3. Now, according to the rule for divisibility, rule for 3, I have to add all the digits, so 2 plus 4, which is 6, and see if the result is divisible by 3. And yes, 6 is divisible by 3 because 6 divided by 3 gives us 2 with no remainder. So for 3, it's a check. Now let's try for 4. The last two digits have to be divisible by 4. Now in this case, we can simply just do 24 divided by 4. Because these are the only two digits. 24 divided by 4 gives us 6 with no remainder. So that's another check. And now that we've met both of our conditions, we can say that 24 is divisible by 12. But to double check that, let us divide. 24 divided by 12 gives us 2 with no remainder. Let's take another example. Let's take 128. Now let's check for 3. So if I do 1 plus 2 plus 8, I get 11. And 11 is not divisible by 3. And if you want to double check that, 11 divided by 3 gives us 3 as a quotient and remainder as 2. So this doesn't work. Immediately, you can stop right here. You don't even need to check for 4. Though this is divisible by 4, it's not divisible by 3. And according to the rule, it has to be both 3 and 4. And so 128 is not divisible by 12. And let's check that. 128 divided by 12. That goes in as 1. Sorry, 128 divided by 12 gives us 11, leaving us a remainder of 7. Proving that 128 is not divisible by 12. Thanks for watching this lesson. If you like this video, please subscribe to my channel, Algebra Star, or visit algebrastar.com. Once again, thanks and stay safe.